Hello everyone, we are Team TechBus and our problem statement title is Real-Time Groundwater Evaluation using DWLR data. Groundwater is central to India's drinking, agricultural and industrial water needs. About 60% of irrigation and 85% of drinking water needs are met by this groundwater. However, over extraction, uneven distribution, and climate change are placing this resource at risk, underscoring the urgent need for sustainable groundwater management. We propose a mobile application that brings groundwater to your fingertips. This is a real time groundwater monitoring app which uses data from 5261 DWLR or digital water level recorder stations along with rainfall, temperature, and soil moisture data to provide instant groundwater status, trend analysis and recharge mapping, AI powered forecasting and anomaly detection, intuitive dashboards for policymakers, and advanced analytics for researchers. Technically, our system will be built using Flutter for mobile app development, Fast API or Flask for backend, MongoDB Atlas for database, AI/ML models like LSTM for prediction, random forest and isolation forest for anomaly detection, and kriging for geostatistics. LLM integration will be used to allow AI driven reports and insights. And finally, visualizations through Plotly, D3.js, and GIS maps. Now, let's see how feasible our solution is and the kind of impact it can create.
India's groundwater. It provides a real-time at-a-glance overview by pulling live data from over 5,200 digital water level recorder stations across the country. The interactive map immediately shows you the status of each station, whether it's stable, stressed, or critical. Key matrices at the top gives you the big picture, like the number of critical zones and overall data quality. And for immediate actions, the recent alerts panel on the right flags a station that needs urgent attention, like the critical depletion we see here. But a snapshot isn't enough. To truly manage our resources, we need to understand the trends. That's where our analytics dashboard comes in. Here, policymakers and researchers can visualize data over different time ranges from 24 hours to an entire year. The average water level trends graph, for example, is crucial for analyzing fluctuations, understanding seasonal recharge patterns, and dynamically estimating groundwater availability. Finally, for a deep dive analysis and informed decision making, we have the reports and analytics section. This screen allows for powerful comparisons. You can see a regional performance summary to understand how different states are managing their resources. More importantly, you can generate detailed station reports that provide graphical data on specific location. This is the information needed to propose targeted, effective groundwater management interventions.
Our solution is not just innovative but also practical. The DWLR infrastructure already exists with 5,261 stations across India. Historical data is available for training AI models. Mock APIs simulate real time streams, and once we get API permissions, we can connect directly to the government datasets. It can also be integrated with programs like Atal Bhujan Yojana for faster adoption. As for challenges, we recognized three major ones. First, data access constraints, for which our strategy is to create a mock API using historical data and later partner with government bodies for API access. Second, data reliability issues. Our strategy here is to use the AI based data imputation and anomaly detection to automatically detect and fill gaps in the data. Thirdly, to overcome forecasting limitations, we collected historical weather datasets via OpenMeteor API to combine multiple datasets like rainfall, soil moisture, and temperature to strengthen predictions. Now, our primary audience include government bodies, researchers, and NGOs and industries. Coming to the impact and benefits, socially, this system empowers policymakers and researchers with transparent data while building public trust through accountable governance. Economically, it reduces the cost of manual surveys and help industries plan water use more efficiently. And environmentally, it promotes sustainable groundwater use, preventing over extraction and supports aquifer recharge.